In cosmology, the steady-state theory is a now-obsolete theory and model alternative to the Big Bang theory of the universe's origin. In steady-state views, new matter is continuously created as the universe expands, thus adhering to the perfect cosmological principle. While the steady-state model enjoyed some popularity in the first half of the 20th century, it is now rejected by the vast majority of professional cosmologists and other scientists, as the observational evidence points to a Big Bang-type cosmology and a finite age of the universe. History: Sir James Jeans, in the 1920s, was the first to conjecture a steady-state cosmology based on a hypothesized continuous creation of matter in the universe. The idea was then revised in 1948 by Frederick Hoyle, Thomas Gold, Hermann Bondi and others. The steady-state theory of Bondi and Gold was inspired by the circular plot of the film Dead of Night, which they had watched together. Theoretical calculations showed that a static universe was impossible under general relativity, and observations by Edwin Hubble had shown that the universe was expanding. The steady-state theory asserts that although the universe is expanding, it nevertheless does not change its appearance over time. The universe has no beginning and no end. Problems with the steady-state theory began to emerge in the late 1960s, when observations apparently supported the idea that the universe was in fact changing. Quasars and radio galaxies were found only at large distances, not in closer galaxies. Whereas the Big Bang theory predicted as much, the steady-state theory predicted that such objects would be found throughout the universe, including close to our own galaxy. For most cosmologists, the refutation of the steady-state theory came with the discovery of the cosmic microwave background radiation in 1965, which was predicted by the Big Bang theory. Stephen Hawking described this discovery as the final nail in the coffin of the steady-state theory. The steady-state theory explained microwave background radiation as the result of light from ancient stars that has been scattered by galactic dust. However, the cosmic microwave background level is very even in all directions, making it difficult to explain how it could be generated by numerous point sources, and the microwave background radiation shows no evidence of characteristics such as polarization that normally associated with scattering. Furthermore, its spectrum is so close to that of an ideal black body that it could hardly be formed by the superposition of contributions from a multitude of dust clumps at different temperatures as well as at different redshifts. Steven Weinberg wrote in 1972, "The steady-state model does not appear to agree with the observed dl versus z relation or with source counts. In a sense, the disagreement is a credit to the model. Alone among all cosmologies, the steady-state model makes such definite predictions that it can be disproved even with the limited observational evidence at our disposal. The steady-state model is so attractive that many of its adherents still retain hope that the evidence against it will disappear as observations improve. However, if the cosmic microwave background radiation is really black body radiation, it will be difficult to doubt that the universe has evolved from a hotter, denser early stage. Since this discovery, the Big Bang theory has been considered to provide the best explanation of the origin of the universe. In most astrophysical publications, the Big Bang is implicitly accepted and is used as the basis of more complete theories. Quasi-steady-state cosmology was proposed in 1993 by Frederick Hoyle, Geoffrey Burbidge, and Jarrett V. Narlikar as a new incarnation of the steady-state ideas meant to explain additional features unaccounted for in the initial proposal. The theory suggests pockets of creation occurring over time within the universe, sometimes referred to as mini-bangs, mini-creation events, or little bangs. After the observation of an accelerating universe, further modifications of the model were made. Other proponents, chaotic inflation theory has many similarities with steady-state theory, however on a much larger scale than originally envisaged. It is the C field and the notion of quasi-steady-state universe that has some resemblance to chaotic inflation theory or eternal inflation, which sometimes posits an infinite universe with neither beginning nor end, in which inflation operates continuously, on a scale beyond the observable universe, to create the matter of the cosmos. However, both steady-state and quasi-steady-state assert that the creation events of the universe can be observed within the observable universe. whereas inflationary theories do not posit inflation as an ongoing process within the observable universe. Criticism: astrophysicist and cosmologist Ned Wright has pointed out flaws in the theory. These first comments were soon rebutted by the proponents. Wright and other mainstream cosmologists reviewing QSS have pointed out new flaws and discrepancies with observations left unexplained by proponents. See also, conservation of angular momentum, external articles and references, criticism, Wright, EL errors in the steady-state and quasi-SS models. UCLA, Physics and Astronomy Department Assis, AKT. Neves, MCD History of 2.7 Kelvin's temperature prior to Penzias and Wilson. Iron 2, 79 Euro 87 References, Hoyle, F. Burbage, G. Narlikar, JVA Quasi-Steady-State Cosmological Model with Creation of Matter. The Astrophysical Journal 410, 437 Euro 457. Bibcode, 1993 APJ. 410-437 doi, 10.1086/172761 Hoyle, F. Burbage, G. Narlikar, J.V. Astrophysical Deductions from the Quasi-Steady-State Cosmology. Monthly Notices of the Royal Astronomical Society 267, 1007 Euro 1019. Bibcode, 1994 MNRAS. 267.1007 Hoyle, F. Burbage, G. Narlikar, J.V. Astrophysical Deductions from the Quasi-Steady-State Erratum. Monthly Notices of the Royal Astronomical Society 269, 1152. Bibcode, 1994 MNRAS. 269.1152 HA. Hoyle, F. Burbage, G. Narlikar, J.V. Further astrophysical quantities expected in a quasi-steady-state universe. Astronomy and Astrophysics 289, 729 Euro 739. Bibcode, 1994 A and A 289 729 H. Hoyle, F. Burbage, G. Narlikar, J.V. The basic theory underlying the quasi-steady-state cosmological model. Proceedings of the Royal Society of 448, 191. Bibcode, 1995 RSPSA 448 191 H doi, 10.1098/RSPA. 1995.0012 Notes and citations. Further reading, Farmer, B.L. Universe Alternatives, Emerging Concepts of Size, Age, Structure, and Behavior. Gilliland Printing. ISBN A0-9649983-4-3 Hoyle, F. Burbage, G. Narlikar, J.V. A Different Approach to Cosmology. Cambridge University Press. ISBN A0-521-66223-0 Mitten, S. Conflict in the Cosmos, Fred Hoyle's Life in Science. Joseph Henry Press. ISBN A0-309-09313-9 Mitten, S. Frederick Hoyle, A Life in Science. Orem Press. ISBN A1-85410-961-8A.